I'm Bob from Hauptwerk Hardware, and today we're going to look at these motorized draw stops. There are basically two types or formats of these. This is the usual draw knob, so pull it out to turn it on and push it in to turn it off. And then there's the tab stop, which is this type. These I think more commonly found in theatre style organs, but sometimes in classical organs along the top of the manuals, and you just simply push that down to turn the stop on and pop it back up to turn it off. Obviously they would normally be mounted in a stock jam like we've got here, so you'd only see them from the front, and the usual pull them out to turn them on, push them in to turn them off. And they look pretty much exactly the same once they're mounted as they do in the screens that you see on Hauptwerk. And I've actually got these connected up to my Hauptwerk system here so that I can pull those out and hopefully you can see them moving on the screen. And when I push them back in, obviously the opposite happens. So why do we need motorized draw stops? Well, basically there's two main reasons. The first one is to keep the real switches, or the real stops, the physical ones, in sync with the ones on the screen, because if they weren't motorized, if I pull these out, obviously they move on the screen and they move when I push them back. Problem comes if I pull them out, they're pulled out on the screen, but if I press general cancel, they pop in on the screen but these don't move, and then Hauptwerk realizes that these are still out, so it pops them back out again on the screen, which is not really what we want. So if I turn the power on now to these motorized stops, and we do the same thing again, if I pull these out, they're out on the screen. If I hit general cancel, they pop in on the screen and they pop in real life as well. And that's why we need them to be motorized, and also for setting up registrations. If you set up a registration on one of the divisionals or one of the general pistons, you want these to be able to move when you press that piston. So I've set up a couple on the end of these generals here, so if I press that one, for example, these four pop out and they pop out on the screen. If I press the next registration, they go back in and these pop out, and again press general cancel and they all go in. And that wouldn't be possible if you did not have stops that moved with or in sync with the stops on the actual screen. So that's the reason they're called motorized, is that they have a, I suppose you could crudely call it a motor, but a system inside them anyway, which allows them to move in and out when commanded by the Hauptwerk software. And also obviously they send a signal to the Hauptwerk software to tell it when you've pulled them out manually. So they can work either way, either manually or when commanded by the Hauptwerk software. So what I'm going to do now is to take a closer look at exactly how these work, because once we understand what they do and how they do it, then it becomes easier to understand or figure out how we can use these with Hauptwerk or any other virtual organ software that we want to use them with, really. So basically, as I said in the just now, when you pull them out it switches on, and when you push them in it switches off, and that is achieved by this little reed switch in here. I don't know if that's visible very well in the shot. If you get the light just right, you can kind of see there's a glass reed switch in here, and then this part of the stop, which is attached to the front part and moves with it. So when you pull the stop out, this has got a magnet in it, and this moves up close to the reed switch, which turns the reed switch on, and when you push it back it moves away from the reed switch and turns the reed switch off. So that's the pretty basic operation. The reed switch is brought out to these two connections here on the back of the circuit board that's attached to the stop. So if you just want to use it as a regular switch and not have it motorized, you can do that. You just use those two connections, which you would connect up to your MIDI encoder, and then it will work on, off, just as an ordinary manual stop. However, that's not what this is about. This is about the exciting stuff of how it can move on its own. So let's take a bit more of a closer look at what it is and how it's made. So basically you've got two circuit boards here, and these have magnets mounted to them, and when you look at it they actually take up quite a lot of you can see it's a magnet, take up quite a lot of area really on the board. But all these are for, they don't do anything electrically, they're just to give the stop that nice kind of damped feel to it, that nice action, because this in the middle being a magnet which operates the stop, the reed switch, in order for it to pass by those other two magnets either side of it, it causes some resistance, because it will they'll repel each other as it goes past, and that tends to make it either pop out or pop in once you get past a certain point. So that's what those are there for. In this section, this black section, basically there are two coils. So let's take a look at one that's not been finished. So by the magic of going to the factory where they're made and getting this before it was finished, we can see basically what's inside here. So at the back you've got these magnets, just the same as we've got on here. We don't have the centre part fitted as yet, so this is all empty in here. The reed switch hasn't been fitted, nothing's been fitted in here at all except for these two coils. So if we unwind this masking tape that's around the edge here, we can see underneath that is just a coil of wire, and there are two of those, one at the front and one at the back, and the connections for them, they're brought out on these little insulated black wires. So two of them come to this point here, which is that point on the circuit board at the top. So that's the start, if you want, of this coil, and the start of this coil are both bored out to that same point, and then the other end of both of these coils comes through to these two connections here. That's that one there and that one there, which are those two connections here, and we can see they haven't been soldered on yet. It's just as it's come off of the machine that made it. So that's what's inside. Let's put this tape back on to protect it. And running up the middle is a little armature like this. Now this is a metal armature, it's iron. Obviously if you get it near a magnet, I don't know if you can, how well you can see that, but the magnet attracts it. And the whole idea of this is that this sits inside there like that. And because you've got two coils, as you'll probably remember from your school days, if you pass electricity through a coil, it turns that coil into an electromagnet. So if you connect power between there and there, so that's both sides of the front coil, what it'll do is this coil becomes a magnet and it will pull this into that position. It will actually make the centre of this part line up with the centre of this, more or less, and then if you apply power to the back coil, it will pull this to be in line with the back coil, and that is what makes these things move forwards and backwards. It's pretty much that simple. So we can look at that, we can demonstrate that with this stop here. If we get some, bring in some power. So this is from my power supply. These are rated at 15 volts nominally, but I've connected the negative from the power supply to the common point. So on here, this is connected to where both of those coil wires go to. So this connects to the start of the back coil and the start of the front coil, and then the other end of the coils come to these two connections there and there. So if I apply power to one of these connections, the stop moves forward, because this magnet here has been, or this coil has turned into a magnet, and it's pulled this into the forward position like that. If I apply power, or the other connection if you want, to the back connection, that's applying power to the back coil, this coil here, and it'll make that move back in. So there we are. I think that pretty much proves what we're saying. So what that's done is that that's applied power to this coil and it's made that move back like that. And all of the other stuff around it is really just cosmetics and mounting. You've got the bit on the front which ends here. This bit, as you can probably see, is there's a little nut in there, so that is this is a bigger stop than this one, obviously, so the armature is bigger in the middle, but you can see that that's where the threaded part of that would be. So that's just screwed onto there. You've got the mounting holes here, the 3 mounting holes here, and this flange on this metal sleeve. The metal sleeve obviously is going over, covering all of that up, and then at the back end you've got exactly the same arrangement as we've looked at there with the reed switch, and then the circuit boards so that these connections are easily available here. And the way they're done, the first 2 at the top are the reed switch, the next one down is the center connection, or the common connection to both coils, and then the next 2 is the on coil and the off coil. And that's pretty much it, really. That is how they work. So if we look at the tab stop version now of the motorized stop, it's a very similar arrangement. Starting off, that we've got this contact at the back here which moves, you can just about see. So when you push the front down, this little pin that sticks out of the metal here, that comes up and makes contact with this strip, and that strip is brought out to a terminal at the back, and the actual pin is connected to the main framework, which is all metal, and that comes out through this connector at the top, which usually has just like a little solder lug on it. So looking at this side, we can see it's very similar to the draw stop in that it has 2 coils. The only difference this time is that the connections to those coils are all separate. So we've got 2 connections here for both ends of this coil, and 2 connections here for both ends of that coil. And the way that this works is that you can see you've got this little pivoted armature which bends around the front of these metal pieces, which are put through the center of these coils. So when you energize this coil, this turns into one pole of a magnet, which will pull this closer to it, simply because it's covering more area of the magnet. So it's basically turning this into a magnet, which is making this attract, and it pulls that up to there. And at the back the opposite happens, and therefore it causes it to pivot in the opposite direction. And then to make it stay wherever it's put, we've got this spring detent arrangement at the back, and these stops are actually mechanically quite complicated. You have an adjustment here for the detent. You have an adjustment on either end for how far this is going to tilt, and therefore how far away from the centre of the magnet this armature is going to be. And you can adjust these. They've got a screw thread down them, but they've got a little screwdriver slot in the top, so you can put a screwdriver in there and screw that in and out to get this exactly how you want it, with the correct amount of movement between on and off. So if we look at this, what I've done is I've connected one end of both the coils together, just like they were on the other stop. Apart from, you have to do that yourself with these, they're not connected to one terminal. So if we do the same thing, we connect our power supply to that. Let's find something to stand the thing on. Let's put it on there like that. Then what we can do is, if I hold that down, connect power to one side, it will turn it off, and the other side it will turn it on. So just like before, exactly the same electrical arrangement. So you've got the 2 coils, one to turn it on, one to turn it off, and then on this side you've got this little, instead of a reed switch, you've got this little pin. But again, just talking about the mechanical complexity of these, this is actually quite clever, because I don't know if you can see, when the pin actually contacts that metal strip, it does actually push the metal strip away from it, and that means, if you watch it closely, that the metal strip and the pin slide against each other. So that sliding action is a self-cleaning action. So every time this is operated, it helps to keep that little strip nice and clean and prevent oxidization and any other problems that you would normally get with open switch contacts. So that's a quick look at how they're actually made and how they work. So now let's have a look at what the requirements are to actually drive these things within our organ system. Okay, so let's take a look now at the options that Hauptwerk gives us for actually controlling our stops. If we right click on one of the stops that we want to control, we've got a number of different things that we can choose from, and when we're setting it up we just go for the auto detect option, and that's nice and easy. However, we want to sort of look a little bit behind the scenes to see what's going on. So if we just look at the options, we go to adjust MIDI trigger settings manually for this particular stop, and our primary input we can set all sorts of different things, launch pads, pistons, stops, etc, etc. But that normally we would not be bothered with, because that would be set by doing the auto detect part. The primary output, however, is the bit that we're interested in at the moment, because that is the signal that's actually going to make our mechanical stop physically move. So it says keep set to no output unless you need MIDI control to control a moving MIDI stop or lamp. So we do need it to move a stop, so we're going to set that to note on off. We've got three options. We've got match the primary input settings, which would be the usual one, because if moving the stop causes it to send a MIDI note on off to Hauptwerk, then that's what we'd want it to send back again to control the stop. So that's the first one of these two, and the second one is a MIDI NIRPin, non-registered parameter number on off as well. The difference between these two is not huge. Note on off only goes up to 127, so the possibles are 0 to 127, and NIRPins go up to 65535 or whatever they are. Actually, it's got it down here, 16383, so less than I thought. But we're only interested with note on off. That's how our device works on here. So we select that. We have to select an output port, so our motorized stop controller is the port that we're going to be using. And then we've got the normal MIDI stuff that you'd select or expect, so we can select the channel number between 0 to 16. We're currently using channel 1, and then you can select which note is going to correspond to this stop. So I don't know, just for argument's sake, let's use middle C. Why not? So that's note 60. Okay, and then we're not interested in NIRPin numbers because we're not using that. We're using note on off. We're not interested in the Novation launchpad thing because we're not using that. And the last option, always suppress output if direct response to input. Now, what that's about is that if you pull a stop physically and it sends a input to this saying that note 60 has been switched on because you've pulled the stop, what you don't want this to do is then send a note 60 back to the stop saying turn on, because then you get a loop. So we switch that so that it says always suppress output, and we click OK. So that's fine. But let's just think about how this works versus how the stops work that we've looked at. So if you were to connect Hauptwerk to a MIDI decoder, which would be the thing, because what that's going to do is it's going to take the MIDI note on off signal that you've sent here, so you've got a test note on and test send note off. So if you connect the output to or connect Hauptwerk to a decoder, pressing send note on will switch on whichever output corresponds to middle C on that decoder. So if you've got a MIDI decoder with 128 outputs, labeled 0 to 127, when you press test note on, 60 will come on and it will stay on, because note on off are pairs. So when you send a note on, it will switch something on, but it won't switch it off when you let go of the button, if you see what I mean. So when you pull a stop, for example, that sends a MIDI note on. When you push the stop back in, it sends the MIDI note off. So if you click send note on, it will switch on that output from a decoder, and that will stay on until you press send note off. So if we close that down, if we click that stop on, that will have sent a MIDI note on channel 1, note 60, middle C, and a decoder would now have switched on output number 60, and it's on all the time now until we press that, and that switches it back off. So coming back to our mechanical stop, if we have a MIDI decoder that's going to control this thing, and it's going to give us a voltage that switches on when it receives a note on, and it switches off again when it receives a note off, all we can really do with that is apply it to one of these coils. So if this is, for example, our note 60 that we just talked about, when it goes on, the stop moves, but now that will stay on. And there's a big problem with that. Firstly, if you want to turn it off, it's holding the stop out because it's powered all the time. Secondly, is it's using quite a lot of power to actually do that. So everything would get very hot very quickly because it's not designed that way. Now, the second thing is that I've removed the power now, obviously, but this power would only get removed, so we get our note on, it stays on. Say we switch the stop off on the screen, it sends a MIDI note off, that removes the power, but the stop's still in the on position. So that doesn't really help us, because what we need to happen is that when the note off arrives, we need it to supply power to the off coil that switches the stop back off again. And we need it to just do that for a short amount of time, because otherwise everything would overheat and everything would go horribly wrong very quickly. And looking at the power this thing actually uses, it's rated at 15 volts nominal, okay, and it says read half an amp. Well, that's just talking about the read switch, so we don't care about that, but the actual coils require 15 volts as it says on this label. Now, I've got my power supply set to 15 volts, and when I apply power to this coil, it's using 3/4 of an amp all the time that I'm connected to it. Okay, so if you do the maths on that, 3/4 of an amp times 15 volts works out at 11¼ watts, which is actually quite a lot of power. And if that was continuous power, we would have all sorts of problems. Now, electrically speaking, this little chip here contains the transistors that would drive 4 of these draw stops. Okay, so this chip will drive 4 draw stops, and this is capable of driving or dissipating, I think it's somewhere around 2 watts, 0.2 watts, hang on, I will check exactly, yeah, 2¼ watts. So the entire package can only dissipate 2.25 watts, and the power required to operate one of these coils is 11.25 watts, and if you had 4 stops, which is what this can handle, that would work out at 45 watts. So this thing would become toast very, very quickly. So clearly we can't do it that way. So just using a MIDI decoder isn't going to work. We need something that's kind of a bit cleverer and is going to do something else. There we go. In summary then, to make these stops work, we need a device that is more advanced than just a simple decoder. Something that will wait for the incoming MIDI note on event for this particular stop number, and when it gets it, apply power to the on coil, but only for long enough for the stop to move into the on position, and then it will just sit there and do nothing until it receives the MIDI note off command for the same note when it applies power to the off coil, but again only long enough for the stop to move. On top of all of this, it has to withstand the higher voltages and currents needed to drive these motorized stops over the simple lamps that would be used in lighted stops. This device is called a motorized stop controller, and this is what I'm going to be looking at in the next video. So I hope you found this helpful, or at least interesting, and if you have, I'd really appreciate it if you could click the like button below, and to make sure that you don't miss the next video, if you want to click the subscribe button and the bell icon to make sure that YouTube can let you know as soon as that video is released. So thanks very much for watching, and I'll see you in the next video.